As you can see, there is the LD1 LED and it is blinking with a delay of 250 milliseconds. See? Okay, let me show you the code. So this is our STM32Cube IDE. You can see that we have used this command hold GPIO right pin, port B, pin 0, set. Set means turn it high. So it's 1 and it's on for 250 milliseconds. This is a delay command. And after that, we use the same command hold GPIO right pin, port B, pin 0, because at pin number PB0 we have the LED, and then we give this command GPIO pin reset. It means set it off 0. So it remains off for 250 milliseconds. Then the forever loop, that is the while one, repeats forever. So that's why this coding gives us this result over here. See? So guys, welcome to learning microcontrollers. In this lecture, I'm going to show you how you can blink an onboard LED using STM32Cube IDE with a Nucleo-STM32H753zi 144 pin package board. So you can see that we have three LEDs here, LD1, 2, 3. We will be blinking one of these onboard LED. We will not be connecting external. So let's get started. So guys, this over here is our STM32H753zi Nucleo board. You can see on the left side, we have these three onboard LEDs, the LD1, LD2, LD3. We will only be blinking one of these. Like we can take LD1. Okay, we just blink LD1. Okay, that's fine. So guys, let me introduce you to the hardware. So this over here is the hardware. As you can see, this is our STM32H753zi based Nucleo board. So you can see that there is the LD1 LED, this one. We will be blinking this one using the programming. So let's get to our STM32Cube IDE. So let me open it up. So this is the STM32Cube IDE. I will be using magnifier to zoom in so you guys can see better. Okay, wait. Okay, just set a path where your files will be created. Click on launch. Wait. Starting the Cube IDE. Okay, started up. Go to the left in the file, click on new, and there you have the STM32 project. Click on it. Okay, wait. It is initializing the new project. You have to wait. Okay, there you go. Now select the board or the microcontroller. As I told you in the introduction video, there is a microcontroller on the board. Either you can write just the name of the microcontroller in the MCU MPU selector, that will be fine. Or if you want to go with the board, just write the name of the board. The name of the board is Nucleo-S753zi. Now go there and check. So there is the board, and it will give you some description as well. This is the exact name of my board. So there you have the description as well. If you are still like confused, you can see the description and verify that this is the right board. Click on next. Write the name of the project. Blinking LED tutorial with H753zi. Click on finish. Here you go. Now you have to wait for the GUI to be initialized. It may take like 20 to 30 seconds. So if your STM32Cube IDE is not updated, click on OK. It is just asking for the LEDs. We will like initialize all the LEDs and button. 2 buttons and 3 LEDs. Let him initialize. Okay. Okay, there you go. It's preparing the GUI. You have to wait for a few seconds. Wait. Okay, here you go. The GUI has been initialized. Now, first of all, what we do is that we go to the LED pin. We have like LD1 LED. We allowed it to initialize all the 3 LEDs and the 2 buttons. LD2 LED, LED2 yellow, and you have button. So we may use any LED. We just go with this LD1 LED. So click on it. You click, right click on it, pin unlocking, and then after that you click on it again and set it to GPIO output pin. Because if you use an external LED, then you have to do this. So better you use the same technique I use right now. So here you go. The LED, we only have an LED at PB0 and we want to just blink it. So that is the only pin we need. Now you go to the project, click on generate code, click on OK. That is yes. Okay. Now it is generating the code. You just have to write your code. You don't have to write everything. Now this is the code generated. The pins are initialized automatically. This is the void main loop starting here. You can see that it initialized all 3 pins. So we do not have to reinitialize them. It also have initialized our COM port for like serial communication, there you will write your code. Now to write your code, you have to need the command. Now to get the command, the best thing nowadays is your chat GPT. You can either go through the data sheets or some STM32 syntax sheet, but I suggest you go to the AI, because AI is nowadays going to do all that for you. So the important thing here is you have to learn how to write the prompt. Now see how I write a prompt. I write here, I have STM32H753zi Nucleo board. You have to learn this, how to write a prompt to get the code. Okay, and I am using STM32Cube IDE. I have an LED connected to pin PB0. Generate me a code to blink that LED with a delay of 1 second. Okay, this is the code. I click on upload, wait, stay logged out. No need of any paid, just free version will do. Okay, it is doing its job. We just need the command syntax, remember that. So instead of going through the data sheet, we are taking help from the AI. Okay, this is the command. Okay, it has used the command toggle pin. I suggest we do it one by one, like we turn the pin high and then turn it low. So I ask him, instead of toggle command, use set and reset. Okay, it is updating the code. So yes, this is the command I wanted. Now these are the command syntax. Instead of like going to the other stuff, like if I go through the data sheets and stuff, I was to get the same. So it is better you take help from the AI. Now copy these 4 commands inside the main loop, because rest is already written there. You don't need the rest. We just need the syntax. Okay, there in the void main, the while loop, there you place your code. Now this command hall GPIO write pin is the syntax. Now GPIO, this is your port, GPIO P. Now port B, pin number is 0. As in the GUI, you have seen that the LED 1 is at PB0. So port B, pin number GPIO pin 0, and pin GPIO pin set. Set means it's high. Like in case of Arduino, you write digital write 8 high or pin number 9 high. So here you write port pin, and then set means it's high and reset means it's low. See, it also shows the help 1. It means it's 0. Reset means it's 0. So that's perfect. So guys, now once the pin is set high, it will get a delay. This is a command to give delay, halt delay, and whatever the delay, this is in millisecond. 1000 means it's a 1 second of delay. It will remain there for 1 second. The LED will remain high or on for 1 second, and after that we reset. Port B pin 0 is reset to 0, and then it remains off for 1 second. Now we burn this code. To burn this code, you have to connect your ST-Link, this device, to your computer. So there you have it. Just connect it to the computer first, and that's all you need. So I do that, and then we move on to the code. Okay, let me connect it to the computer first. Here you go, it's connected. Okay, now it's connected. Now after the device is connected, you do not need an ST-Link, because it already have an onboard ST-Link chip. So click on this button called run. It is building the project. Wait, check for errors. Okay, 0 error, 0 warning. That's perfect. This window pops up. Click on OK. Okay, now it will ask to burn it. Click on OK. Wait, waiting for debugger connection. Waiting for debugger connection. Okay, raising, download successfully. Okay, the code has been transferred successfully. Now go to the hardware to see is it working or not. So this is the LD1 LED. You can see that it is blinking. So this is working fine. It stays on for 1 second and then turns off after 1 second. See, now we change the delay. Let's play with the code. We go back there. Now I change the delay. Instead of 1000, like 1 second, I make it 250. Like it will remain off for 1/4 of a second, that is 250 millisecond. And then it will turn off after 250 millisecond. So that is, I click on build again. Okay, let it build. Click on OK. Okay, it's built without error. If it is built without error, it will automatically start burning it. So it is waiting for the debugger. Okay, download, verified successfully. Okay, that's perfect. Now go to the hardware to see the new code. See, the blinking speed has increased. So this means that it is now on for 250 milliseconds, then turns off. So this is it, guys. It is very simple. So I hope you guys learned something from this lecture. So if you have any questions, you may ask. We'll see you in the next lecture. Goodbye until then.